start at 60. I want to go to 60 over there. So is that going to 60 or too short?
Yes, it's going to 60.
Pretty good?
Yep.
Now, by the way, I'm adding to the pendulum because if I don't add to the swing, I lose. And what's going to stop it? Air friction, friction on here.
Physics.
Physics, yes. So otherwise, so am I being accurate? So do you need to stand where the firm line is or where the dotted line is?
You're a little bit short at the moment.
A little bit short.
Now I keep seeming to be a little bit, I'm always a little bit short. I've had those jokes all my life. But from where I'm looking here with the parallax, I'm not quite seeing where it's going. So being at any moment, you decide to do 10 cycles, so you might go, start, 1, 2, am I going too far? 3.
Maybe just a tiny bit, but like, yeah.
And you time 10 for me, okay? And then the rest of you can time 10 as well. And I'll get you 4 answers and see how different they are. So, am I going good or not?
Yeah.
Then we're going to graph it and talk about all the numbers and what graph. I want an equation for its motion, by the way, of its position. I want a graph for the motion of its position and of its velocity and of its acceleration. So anyone start the counter? Do you have a stopwatch or not on your phone?
1 is back and forth, right? That's 1.
Yes, so yeah.
Every time it hits the line, basically.
It took 18 seconds to do 10.
Good.
It took 17.96 for me, which is pretty much 18.
Oh, that's impressive. So we're talking about 10 cycles. Why am I getting 10? I get 1, it's too inaccurate. I might have been short.
18.2.
Oh, this is impressive. So we got 18s.
18's and a 17.
Yeah, so close enough to say 18. The period, I'm going to put here for the 60 centimetres, was about 18 seconds. Oh, I like it.
This is just going to look like a...
Yeah, tell us.
I was going to say it's going to look like a sine curve, but...
Depends on where you start. So if I start there timing, I've got a sine curve. If I start there timing, I've got a cos curve. If I start there timing, I've got a minus cos curve.
I was like, wait.
And if I start that direction, it's a positive sine curve. If I start that direction, it's a
Negative.
So it's your choice where you start. I know I probably need a bigger screwdriver. That's probably better.
You're gonna need a bigger pump. Has anyone else seen that ad? Just me?
Yeah.
Okay.
So I'm going to go out here to 80. I'm actually going to go past 80 because I know I've got to do the friction, I've got to adjust it. Okay? I should start parallel to the board, otherwise they're going to put it out of whack and swing it everywhere. So you can time whenever you want for 80 once it looks like I'm doing a good job.
You're pretty spot on at the moment.
Clicking. Too far?
Maybe just about right.
Good part is dividing by 10, you can just tell me the answer anyway. I was going to go 5 and I went that.
18 seconds again.
18 again.
Interesting.
Nice.
So will it always be the same? I'm trying to think who it was, I think it was Galileo.
18.3 for me.
Yeah, 18.5.
Even though it's going further.
So if it's going further, does it go longer or shorter? Okay, so let's go through the maths. So, what am I going to call this, by the way? What am I going to do when I draw a graph of it? I want its position, and when we're talking about position, we're talking usually about x, and then we're talking about velocity, and then we're talking about acceleration. So we want its position, its velocity, and its acceleration. So if we started timing from here, that's when t was 0. Okay? So when time was 0, what was my position? From the centre.
1 unit.
60 centimetres from the centre, which I could call 0 anyway. So at time 0, I was at 60. Let's call that 60. So what happened when I got to, I need to figure out what this time is. So what do I need to get the time? How long did I take to do a cycle? Oh, it wasn't 8, it's 1.8.
It is.
Per cycle.
Yes, so I should have just said that's 1.8 seconds, and that was about 1.8 seconds. So when I say period, it's talking about per cycle.
Yeah.
So this now becomes 1.8, 0.9, 0.45, and 1.35. I could put them on there. And yeah, this, some of you see it all in your head, maybe, I don't know. So it's position. So how many times have I taught this in the past? A lot of times. Never done it like this. And I saw some people just got it and they was there and they started dreaming. It's dangerous when I start dreaming. Okay, so after 1.8 seconds, where was it? Back to 60.
Beginning.
So I've gone there, 1.8 seconds, back to there. So after 1.8 seconds, I'm back to 60. Where was I after 0.9 seconds?
0.
Which you already saw in your head. No, I'm not back to 0. Where am I back to? Yeah.
Oh, the way.
So you got to stop and get your brain around of there, and you can start to see what curve I'm forming.
Yeah.
After nearly half a second, after 0.45 seconds, I'm at 0. Coming back again after 1.35 seconds, I'm at 0.
So it's like 60 cos.
Yeah, can you imagine you could actually stop the video and go click?
Yeah.
You started then and click stop on 0.3 seconds and get your number. Stop on, I don't know, 0.6 seconds and get your number. And then you go, oh, this reverse upside down symmetry. Yeah? So, let's talk about what's happening though. I would rather talk about the idea of what's happening. There it is. Oh, don't do it there. When I first start here, what's its velocity?
0.
0. So its velocity there will be
0.
instantaneously 0. Go back to your calculus. This is going to be all calculus. My velocity there will be the max, fastest, whatever you want to call it. But this way it's going to be a max negative. Coming back it's going to be a max positive. So by the way, when it first starts, what's happening to its velocity? Increasing, 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 negative max, decreasing, 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 0. So it's covering a larger distance here than it was back here. So in the 10th of a second it mightn't have gone very far. And the next 10th of a second further, next 10th of a further, and you see it's accelerating. And you can go through the acceleration. So by the way, this thing is going to be not moving as far in the beginning, but then it's going to speed up. Oops, missed it. And then it's going to slow down, turn around, and we're forming, without even any great big mathematical understanding, we're forming a curve, and we want the equation of that curve.
Yeah.
So we're going to have what curve? Sine or cos? It's whether you want. I would rather it be a 60 cos. Because I'm used to, if it starts up there, I'm going to go with 60 cos. You okay? What do we have to work out? That thing there. So we're talking about y compared to t. So the big thing is getting that number there. Now we've been calling it n all the way through. When it comes to simple harmonic motion, people like to call it k. The old k comes back again. So what's the period? Let's go back to this. The period of sine or cos, sine or cos. You remember it?
Something on 360. On 360.
Are they ringing?
360 on.
Yeah. So if we had y equals cos 2x, the period is. Oh, by the way, how long is a cos period normally? On the basic one.
60 degrees.
What's the period of y equals cos x? What's that number there?
2 pi.
2 pi. Could say 360. We're going to be talking in terms of radians, because we're going to use calculus. So what happens for a 2x? Does a 2x on the inside spread it out twice as wide, or does it make it twice as skinny? Does the opposite of what we expect, makes it twice as skinny.
It does two things within the space of one.
Yeah, so this one has a period not of 2 pi, has a period of pi. So what's the cos of 4x have a period of? And if you don't want to think about it, you just call it 2 pi divided by n, and just go with, we're going to call it k. So that'll be 2 pi divided by 4, okay, which is pi on 2 is this period. Oh, by the way, if we do that roughly, about 3.1 divided by 2 is a period of what? 3.14 divided by 2 is 1.57. We want 1.8. How nice will it work out? Let's go back to just the rule. Forget about all this stuff for a second. But I knew a lot of people will forget that. So we're revising other topics as well. So the period for this graph is going to be 2 pi on n, or in this case k. We want to find k. What was that period? Yeah, 1.8 equals 2 pi on k. Go back to your solving equations. Which way do you think?
Yeah.
K equals?
2 pi on 1.8.
How are your decimals?
Not good.
I can go back to times by 1. Surprising what year 12s do when they haven't done decimals for a long time. Move a decimal. I could have just got 20 on 18. Or I can go times 10 on 10. I've got 20 pi on 18, and k is 10 pi on 9. So the equation of the position for this, which I call y, I should call it x because we're talking about x when we're doing linear motion. We're analysing this in terms of going back and forwards. So we're actually analysing in 2 dimensions. So here we got it, that's it. What was k? 60 cos of, that's not too bad, 10 pi on 9t. So a little bit more, velocity. So at the start, what was its velocity?
0. It's the same graph.
Yes. You go up here, and you go, wait a minute, what's its velocity going to be? When does it reach its maximum?
At 0.
So it's velocity, by the way, which way is the velocity going? Are we going negative direction? Then we're coming back to positive direction. I feel myself almost doing a pendulum while I'm doing it. It's like, you know. So, what's the velocity? So, velocity 0. Velocity is the max in the negative direction. So it's going to be down here somewhere at 0.45. What happens to the velocity when it gets to here?
0.
Back to 0. What happens to the velocity when it's there?
Positive 1.
Maximum in the positive direction. And when it gets back to there, the velocity is 0. So there it is at 0. What graph am I forming now?
Sign negative.
Yeah, it's a sign. Which sign is it? Quick rule. If I differentiate that one, I get the velocity. In this topic, they don't like saying velocity, they like calling it x dot. Differentiate that, what do I get? Cos becomes a?
Minus sign.
The 60 is there for the ride, minus sine, that stays the same. And what do we times by?
10 pi on 9.
The derivative of the inside, which is 10 pi on 9. And so we now got that our velocity is, what's I'm going to write? Minus 10 pi on 9. I'm not going to simplify. That one and that one. Times what? 60 sine 10 pi on 90. Are you convinced that that's true? Now, if I wanted to now, I can go get the second derivative. What's the second derivative called?
Wait.
Acceleration.
What's the derivative of
Oh.
the velocity?
I was like, the second derivative is called the second derivative. What do you want from us?
So that's our velocity, and after velocity comes
Acceleration.
acceleration.
Why didn't you simplify?
Because of what's going to come right now. The moment, the PDH, the resistance, the moment I've been looking for. If I differentiate that, you got this minus 10 pi on 9, you got a 60. What's the sign? What's the sign become?
Minus. Oh, that becomes cos.
Yes, and you see it all in your head. But let's write it for a moment. Derivative of sine is, derivative of sine
Cos.
is cos 10 pi on 9 t times by the 10 pi on 9 again. So both times we're going to times by that thing. So if I wanted to write it, I could say this is a minus 10 pi on 9, and I've got that squared. I've not got the minus squared, have I? So for those at the front, the minuses at the front, and Joshy, I've got this thing here, times by 60 cos tan pi on 9t. What's this? Where we started.
Oh,
This is the whole concept, this is the whole point of me even bothering doing all this stuff.
the numbers.
I got minus some number, 10 pi on 9 squared, times x. So the acceleration is the negative, what's that number?
The period.
Not the period, the k from the period. Okay, that's not the period, it's the k from the period. So you've seen some actual measurements worked out. So it's that thing there, so it's actually minus k squared times x. And there is the whole formula for simple harmonic motion.
Hooray, look at that.
I like it, it's nice. It's a pretty, I think it works well.
That was really good.
And you're really happy with the 18, which become 1.8.
Yeah.
Let's have a look at what it means. Acceleration will be the minus of its position. Here's the big one. Some of you are switching off. The acceleration is a minus of its position. So if I was there, what's its acceleration?
Negative 60 meters per second.
Yeah, you could look at what it is there. So that's accelerating that way. It's accelerating, it's a positive position, 60 centimeters, but it's accelerating as a negative. Acceleration is 0. It stopped accelerating. So I'm accelerating what? Negative.
That's 60.
Positive.
Yes. So I'm accelerating in that direction when I'm going in that direction, which is positive acceleration. And that's what does people's heading. When I'm at minus 30, which way am I accelerating? I'm accelerating at some number k, and I'm going to go to the negative of its position. What's its position?
Negative.
Negative 30. So the negative of negative 30.
So that gets.
You see, you've got to think that.
Accelerations, I don't want to pull it this way, so that slows down. And then it's
So band,
so sad.
accelerating negative, accelerating 0, accelerating positive, accelerating now, it's obvious, ready, set, positive, accelerating what?
0 and then negative.
So I think that makes sense. So people talk about the acceleration is always faced towards the origin.
It's getting big fast as it goes closer. Yeah.
So I like to talk about, ready, it's decelerating. It's accelerating positive. What happens when I get to there? It's slowing down. So slowing down is decelerating. So I'm going acceleration in the negative. Oh my goodness, see, it does people's heading. Yeah? But that's the basis behind it. Now we can go do some questions. Or we can go through your test paper. That's the finish of that. Enough said. All the little bits in there, Ben, did they sink in? The number in there is not the period. It comes from the equation for a period or the calculation of a period. Acceleration goes back to the original equation, which is an x, which you put in there. So the big issue is finding that k. Where does k come from, Josh? Calculating this period gives us the k, which is that value there. And I don't put the squared on the negative, it's only the square of the k, and then you put a negative on it. Okay, enough said, done. You guys look brain dead. You've just been listening too long. I don't like talking that long, I'll turn that off.
That was good, thank you.
It's okay, thank you, you're welcome.